Okay, and now we'll continue with higher level exercises, okay, that are also to verify that. I have here the first one. We have to verify that cosine power 4x minus sine power 4x equals to 2 cosine squared x minus 1 equals to 1 minus 2 sine squared x. Okay, so here I have three statements to prove. So I'm going to number them. Here is statement 1, here is statement 2, and here is statement 3. Usually when I have to prove that three statements are equal, my plan is to prove that the first two are equal. I prove that 1 equals 2. I also prove that 1 equals to 3 or 2 equals to 3, whatever. And by comparison, I can get that the three statements are equal. So I can prove 1 equals to 2 and 1 equals to 3. And thus I will get that the three statements are equal, or I can prove that 2 equals to 3. But here it's easier to prove that 1 equals to 2 and then 1 equals to 3. So I'm going to start by proving statement 1 equals to statement 2. If you remember, we've seen this before, okay? We've seen that cosine power 4x minus sine power 4x can be factorized using the identity of the difference of two squares, if you remember. Let's write it. We have here cosine, if you remember, squared x plus sine squared x, and here cosine squared x minus sine squared x. Okay, and as you remember, this is definitely equals to 1. We should never forget this famous identity. Cosine squared x, without square it doesn't work. Cosine squared x plus in the middle, sine squared x is always equal to 1. Now I'm going to get cosine squared x minus sine squared x. I haven't verified it yet. I haven't verified that this one is equal to this one. If you take a look at this one, sine squared is not appearing, so I have to get rid of sine squared x. What should I do to get rid of sine squared x? What I should do is to remember the identity that says that sine squared x is equal to 1 minus cosine squared x. So I have to remember this identity that says that sine squared x is equal to 1 minus cosine squared x. So I keep cosine squared x, I keep the minus sign, and I open parentheses to replace sine squared x by 1 minus cosine squared x using this idea. Now, introducing the minus sign, I'm going to get cosine squared x minus 1 plus cosine squared x, which is 2 cosine squared x minus 1, which is statement 2 that is verified. Okay, so I will repeat. First of all, I used the difference of two squares to factorize cosine power 4x minus sine power 4x. I got cosine squared x plus sine squared x into cosine squared x minus sine squared x. That's equal to 1, and since I have a multiplication here, then all what I get is cosine squared x minus sine squared x. To reach this one, I must get rid of sine squared x. So all what I did is to replace sine squared x by 1 minus cosine squared x. Then I introduced the minus sign. So I got cosine squared x minus 1 plus cosine squared x, which gave me 2 cosine squared x minus 1 is kept. And thus, these two statements are established or verified. Now, I have to continue to establish that statement 1 is equal to statement 3. I don't have to repeat the factorization, I just have it. All what I reached was cosine squared x minus sine squared x concerning side 1. So the answer of this is cosine squared x minus sine squared x. Now if I look here at the third statement, there is no cosine squared x, so I'm going to get rid of cosine squared x. So I'm going to use this identity. So I will get rid of cosine squared x by replacing it by 1 minus sine squared x. And I already have minus sine squared x. Then adding these together, I will definitely get 1 minus 2 sine squared x. Thus, this one is equal to this one, and this one is equal to this one. Then by comparison, the three statements are equal, are established. Now the final example is very nice. We have to prove that minus 2 sine x into radical 1 minus cosine squared x minus 2 cosine x into radical 1 minus sine squared x equals to minus 2, where x is acute. I have to replace 1 minus cosine squared x by something that can be got outside the radical. Okay, so I keep minus 2 sine x outside. In this radical, I'm going to replace 1 minus cosine squared by sine squared x. Also, I keep minus 2 cosine x outside, and in the radical I'm going to replace 1 minus sine squared x by cosine squared x. Thus I will get minus 2 sine x into sine x. Because x is acute, then I'm going, and this issue will be taken next year inshallah in grade 10. So radical sine squared x is going to be positive sine x minus 2 cosine x into cosine x again. Thus, what do I get? I get minus 2 sine squared x minus 2 cosine squared x. Simply, I can take minus 2 as a common factor. Then inside I will get cosine squared x plus, sine squared x. Let's erase it. So inside, it never matters, but I have to write it in order. I will get 2 minus 2 outside into sine squared x plus cosine squared x. What about this one in the parentheses? It is 1, and thus I'm going to get minus 2.